If you've ever looked up at the night sky and felt tiny, you're not alone. And trust me, you should. Because what's out there makes everything on Earth look like a drop in an endless ocean. And if that sounds dramatic, well, it's space. Drama is kind of its thing. You've probably heard the phrase, "There are more stars in the universe than grains of sand on Earth." Sounds poetic, right? But it's also true, at least according to astronomers' best estimates. There are roughly 10 sextillion stars. That's a 1 followed by 22 zeros. Imagine holding a handful of sand at the beach. Now imagine each tiny grain being its own sun, surrounded by planets, moons, maybe even life. And that's just one handful. Multiply that by every beach, every desert, and every grain you can't even see, and you still wouldn't come close. It's like trying to count raindrops in a hurricane while blindfolded. And speaking of impossible to imagine, let's talk about something that makes your gym weights look like toys. A single teaspoon of a neutron star would weigh billions of tons. Yeah, billions. To put that into perspective, that's about the same as Mount Everest in a spoon. Neutron stars are what's left when massive stars explode in supernovas. They're so dense that atoms collapse and protons and electrons literally fuse into neutrons. It's like squeezing the entire population of Earth into a single sugar cube. If you somehow tried to lift that teaspoon, you wouldn't just fail, it would crush right through the ground beneath you, all the way to the planet's core. And no, that's not an exaggeration. The physics checks out. Space isn't just big, it's weird. It's full of things that break our understanding of matter, energy, and logic itself. So, if a handful of sand can't compare to the number of stars, and a teaspoon can outweigh mountains, what could possibly top that? Well, get ready because the sun, the fiery heart of our solar system, is about to make all of that look small. So we've seen how space can crush your brain with numbers and density, but now it's time to meet the real heavyweight champion, our sun. The sun isn't just a glowing ball in the sky keeping your mornings bright and your beach days warm, it's a monster, a gravitational giant that controls everything in our solar system. In fact, it contains 99.86% of all the mass in the entire solar system. That means everything else, every planet, moon, asteroid, and even you make up less than 1% of what's out there. Basically, we're just crumbs orbiting a cosmic furnace. And that furnace burns hot. The sun's core reaches around 27 million degrees Fahrenheit, where hydrogen atoms fuse to form helium, the same process that powers hydrogen bombs. Every single second, it releases more energy than humanity has produced in all of history. So the next time you complain about your electricity bill, just remember the sun's been doing it for 4.6 billion years straight, and it hasn't paid once. But here's where things get wild. Our sun, this enormous, blazing star that can fit 1.3 million Earths inside it, is actually tiny. There are stars out there that make our sun look like a candle next to a bonfire. Take UY Scuti, for example, one of the largest known stars. If you replaced our sun with UY Scuti, its surface would stretch far beyond Jupiter's orbit. You could literally fit the sun inside it millions of times over. Some of these supergiant stars are so massive that when they die, they don't just explode, they collapse into black holes, ripping space-time apart. And that's the terrifying beauty of it. What looks peaceful in the night sky is actually a violent, chaotic dance of cosmic energy. But if you think big stars are impressive, wait until you realize what the universe itself is doing. Because while stars might rule their local systems, something much larger and far stranger is controlling everything. And it's not slowing down. It's speeding up. Imagine this. The universe isn't just growing, it's running away from itself. Galaxies are moving apart, and the farther away they are, the faster they go. Some are moving so fast that no matter how powerful our telescopes become, we'll never see them again. It's like watching friends drift off into the distance, except they're entire galaxies, and they're moving faster than light can reach us. This is because the universe is expanding, and that expansion is speeding up. Astronomers discovered this in the late 1990s, and it completely changed our understanding of everything. The force driving this? Something mysterious called dark energy, a form of energy we can't see, can't touch, and still don't fully understand. Scientists think it makes up about 70% of the entire universe, but we have no idea what it actually is. It's like the universe has a secret engine running under the hood, and we're still trying to figure out what kind of fuel it's using. But space doesn't just mess with size and distance, it plays tricks with time too. Take Venus, for example. On Venus, one day is longer than an entire year. Yeah, you heard that right. Venus rotates so slowly that it takes 243 Earth days to spin once, but it only takes 225 days to orbit the Sun. That means a day on Venus lasts longer than a Venusian year. Imagine waking up for work, going through your whole day and realizing it's still Tuesday and will be for the next 8 months. And that's not even the strangest part. Because of how Venus spins backwards compared to most planets, the Sun would actually rise in the west and set in the east. So if you ever visit, don't trust your compass or your clock. The universe bends rules we thought were absolute. Space isn't a peaceful void, it's a cosmic magician constantly rewriting reality. But if time can twist and the universe is stretching faster and faster, what about the parts we can't even see? Get ready, because next we're diving into the most mysterious truth of all. We've barely scratched the surface of what's really out there. Here's a wild thought. Everything we've ever seen, every planet, star, and galaxy, makes up less than 5% of the universe. The rest, completely unknown. About 27% of it is what scientists call dark matter, and roughly 68% is dark energy. We don't know what either of those things really are, but we know they exist because of how they affect gravity and the movement of galaxies. Think about that. Humanity has built telescopes that can peer billions of light years into space, yet 95% of the universe is still invisible to us. It's like reading a massive novel, but realizing we've only seen the first few pages and they're written in a language we barely understand. And even stranger, this mystery stuff isn't scattered randomly, it holds the universe together. Without dark matter, galaxies would literally fly apart. And without dark energy, the expansion of the universe might have stopped long ago. So the most powerful forces in existence are the ones we can't even see. And if that isn't weird enough, space also plays by rules that would break every lab experiment on Earth. For example, did you know that in space, two pieces of the same clean metal can fuse together instantly? It's a real phenomenon called cold welding. There's no air or moisture to form a barrier between the metals, so their atoms just connect like they were always one solid piece. Imagine trying to fix your satellite, only for your wrench to suddenly become part of it. Not ideal for repairs, but a perfect example of how bizarre space can be. And this is just the stuff we know happens. We haven't even explored the vast emptiness between galaxies, or what lies beyond the edge of our observable universe. Every new discovery seems to raise twice as many questions as it answers. So far, we've seen impossible densities, mind-bending time loops, and invisible forces that shape reality. But there's one final part of this cosmic story that outshines them all. Because if you thought the universe was big before, wait until you realize how close the impossible really is. By now, we've seen the mind-bending scale of the universe, but let's bring it a little closer to home. How big is space really? Big enough that you could fit every single planet in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune between Earth and the Moon, and with room to spare. It sounds fake, right? The Moon feels so close when you look up, yet it's 238,900 miles away. That's a distance so vast that you could line up all the planets in a nice little row, and there would still be about 5,000 miles of extra space left over. Our solar system plays tricks on scale. Distances that look small from Earth are unimaginably huge once you start measuring. But that's nothing compared to what lurks in the dark: black holes. These are the universe's ultimate power vacuums, regions of space where gravity is so intense that nothing, not even light, can escape. Astronomers estimate there are millions of black holes in our galaxy alone. Most of them are completely invisible, hiding in the dark, detectable only by how they warp the light or pull on nearby stars. They form when massive stars collapse under their own gravity, crushing all their mass into a single point called a singularity, where the laws of physics simply stop working. Space and time stretch, twist, and fall inward, creating what's essentially a one-way door out of the universe. If you fell into one, you wouldn't even notice crossing the edge horizon, the point of no return. But to an outside observer, time would appear to freeze. In a way, black holes are like cosmic mirrors, showing us just how fragile our understanding of reality really is. From the grains of sand that can't compare to the stars, to the monsters that devour light itself, space is more than vast. It's a mystery, a paradox, and a reminder of how small we truly are. And yet, that's the beauty of it. We live in a universe filled with impossibilities, and somehow we're here to witness them. If that doesn't blow your mind, maybe nothing will.